Hey guys, I'm Aiming from Lotus Hub and welcome to another segment of our videos. Today we are going to focus on the extruder hot end assemblies, the temperatures they can reach, as well as the materials they are made of. Be sure to check out our description down below for certain segments or features you want to focus on. In this segment, we are going to focus on the extruder hot end assemblies, the temperatures they can reach, and the materials they are made of. So as we all know, the materials of your 3D print is dictated by the material loaded into your printer. These materials all have different melting points from each other, and at minimum will require a hot end assembly that can get to these temperatures. Let's take a look at some of these materials first. The most commonly materials used these days are the low temperature filaments like PLA, ABS, PETG and HIPS. These materials are usually easier to handle, can be utilized by most desktop 3D printers, and importantly, are relatively cheap to obtain. However, as the 3D printing industry is constantly coming up with new ways to disrupt the market, there has been a wave of higher temperature 3D printing materials that are quickly becoming popular. Materials like PEEK and PEI are rapidly gaining traction in the industry due to their high heat, chemical, and abrasion resistance. With this in mind, naturally extruder assemblies that can reach higher temperatures can cater to a wider range of 3D printing filaments and materials, making them way more versatile in the long run. However, you should keep in mind that while high temperature hot end assemblies have a broader range, there are still some cons associated with them. First, they are more expensive than typical printers. Secondly, printing higher temperature materials can be a huge challenge, generally not recommended for beginners. Materials like PEEK and PEI have adhesion problems and require strict heat management and modified slicing parameters to be effective. In addition, clogs can happen if one is loading a low temperature filament after using a high temperature filament. Lastly, the printers need to have heat insulation and high temperature heated beds to print the high temperature filament reliably as well. Hence, you should really only dabble into high temperature filament printing once you have a really good feel with the easier to work with low temperature filaments. The other part we would like to address is the material of your extruder nozzle. This ties in heavily with the materials used in 3D printing, as abrasive harder filaments have a tendency to wear down the nozzle heads. Worn down nozzle heads are much less accurate in extrusion and will cause significant decreases in print quality. The most common nozzles in 3D printer heads are usually by default brass heads. Brass is relatively soft and can handle soft filaments like PLA and ABS. As we go higher up the hardness and abrasive scale into filaments like carbon fiber and glass fiber infused filament, we will correspondingly need nozzles of harder material. Stainless steel nozzles are increasingly becoming common for this use. For those who would like the luxury of the hardest nozzles around, sapphire nozzles are also purchasable, but unless you're running some very specialized hard and abrasive filament, we would give a pass on those. All in all, if you're just starting out, we recommend you get a normal printer with brass nozzles, learn more about the quirks and possibilities of 3D printing, and move on to more advanced materials later on. As you grow in this journey, most 3D printers and their companies will provide you upgrading solutions to give your printer these capabilities as you need them. We hope that this has been educational, and we'll see you in the next one.